Welcome student. Today my topic is binomial distribution of probability. Before starting a problem, I want to give you one example. Suppose a coin is tossed 20 times. What are the probability of getting 15 heads? Okay. This type of problem we apply binomial distribution. What is the main character of this type of problem? Point number 1 is repeated trial or multiple draw. Point number 2, the probability of each trial is constant and independent. Point number 3, the outcomes are classified under two categories. These are the main criteria for application of binomial theorem of probability. In my example, a coin is tossed 20 times. That means it is a case of repeated trial. Okay. Next, the probability of each trial is constant and independent. Why it is constant? It is the probability of head or probability of tail is also constant and independent. It is one event and has no effect on other event. Okay. Next, the outcomes are classified onto two categories. That is either head or tail. Okay. So this criteria is important for applying binomial distribution. Next, come to our formula. Okay. In binomial distribution, our formula is probability of x equal to n combination x into p to the power x into q to the power n minus x. Okay. Here n is number of independent trial. Okay. Probability p equal to probability of favorable cases and q equal to 1 minus p, and x is favorable number which tends to 0 up to 1, 2, 3 up to n. Okay, that is n number of independent trials we want to get. Our favorable case is x, so we want to get the probability of x. Okay. Next, again the conditions. Point number 1, the random experiment is performed repeatedly a finite and fixed number of times. That is called n. Point number 2, the result of any trial can be classified only under two mutual exclusive categories called success and failure. For a coin, there are two events we can easily determine, head and tail. But in case of dice, if our favorable case is 6, then the opposite result will be non-6. Okay. So there are only two categories of mutually exclusive event. Okay. The probability of success in each trial remain constant and does not change from one trial to another. The probability of single trial is constant and will not be changed. Okay. The trials are independent so that the probability of a success in any trial remains unaffected by the result of other result. Okay. Next is mean equal to NP, variance equal to NPQ, and standard deviation equal to root over NPQ. Okay. Here this is the theory part. I think you have understood. This is problem number 1. 8 coins are tossed simultaneously so that the probability of obtaining at least 6 head is 37 by 256. Okay. Solution. It is a case of repeated trials, so binomial theorem will be applied. At least 6 head means 6 or 7 or 8 head. Okay. It is given that at least 6 head. So at least 6 heads means 6 or 7 or 8. Okay. Probability of head in a single trial is P equal to half. Therefore, Q is also 1 minus half, that is equal to half. That we know. Here, number of trial N equal to 8. Next, the formula of binomial distribution is probability of x equal to n combination x p to the power x into q to the power n minus x. So, probability of 6 head equal to 8 combination 6 into half to the power 6 into half to the power 8 minus 6. Okay, and this comes to 28 to into half to the power 8. Similarly, probability of 7 head 8 combination 7 into half to the power 7 into half to the power 8 minus 7, it comes to 8 into half to the power 8. And probability of 8 head equal to 8 combination 8 half to the power 8 into half to the power 8 minus 8. It comes to half to the power 8. Then we have to add the probability. This would be 6. Probability of 6 plus probability of 7 plus probability of 8 equal to 28 into half to the power 8 plus 8 into half to the power 8 plus half to the power 8. It becomes 37 by 256. Okay, it is proved. This is my second problem. The probability of a bomb hitting a target is 2 by 5. 4 direct hits are necessary to destroy a bridge completely. If 6 bombs are aimed at the bridge, what is the probability that the bridge will be destroyed? Okay. So for a single trial, the result is 2 by 5. Okay. 4 direct hits. That means 4 direct hits are necessary to destroy the bridge. It means at least 4 direct hits are necessary. Okay. Therefore, if 5 or 6 bombs are hitting the target, the bridge will be also destroyed. And 6 bombs are aimed. That means our n equal to 6 as per binomial formula. Now come to our solution. It is a case of repeated trials, so binomial theorem will be applied. Probability of bomb hitting the target is P equal to 2 by 5. That means for a single trial it is 2 by 5, and therefore Q, the failure, equal to 3 by 5. 1 minus P, that is 3 by 5. Here number of trial n equal to 6. Therefore at least 4 direct hits are necessary to destroy the bridge. So our favorable cases are 4 or 5 or 6. These are the 3 alternative cases, and ultimately these 3 results will be added. Okay. Therefore the probability of x equal to n combination x into p to the power x into q to the power n minus x. Next, probability of 4 bomb hitting the target. That becomes 6 combination 4 into 2 by 5 whole to the power 4 into 3 by 5 whole to the power 6 minus 4. This result becomes 15 into 2 to the power 4 into 3 square divided by 5 to the power 6. Next, for 5, that means 6 combination 5 into 2 by 5 whole to the power 5 into 3 by 5 whole to the power 6 minus 5. It becomes 6 into 2 to the power 5 into 3 divided by 5 to the power 6. Similarly, probability of 6 equal to 6 combination 6 into 2 by 5 whole to the power 6 into 3 by 5 whole to the power 0. Why 0? This is 6 minus 6. The result comes to 0. Therefore, what is the ultimate result? 1 into 2 to the power 6 divided by 5 to the power 6. Okay. Now, finally, we have to get the probability of 4 or 5 or 6. That means 3 probability will be added because there is or alternate happening. Therefore, we putting the value of 3 probabilities and then we have to add it. Okay, that becomes 112 by 625. Please check the calculation, and therefore we go to our third problem. Okay, now this is the calculation for binomial distribution. Next, this problem is a back calculation. Okay, so how we have to solve the problem, we see. In a in 8 independent trial of a random experiment with a constant probability of success in each trial, it is known that the probability of 5 success exactly equal to the probability of 3 success. If the experiment is repeated 6 times, what is the probability of obtaining 4 success? So this question we have to, probability is not given, but number of trial is given, that is 8 independent trial, and also one another point, that is the probability of 5 success is equal to probability of 3 success. Okay, now we have to try to solve the problem. Here it is a case of repeated trials, so binomial theorem will be applied. Okay, number of trials n equal to 8 given, and it is also given probability of 5 equal to probability of 3. Then we put the formula n combination x into p to the power x into q to the power n minus x, but instead of q here we put 1 minus p, because we know q equal to 1 minus p, so we put 1 minus p. Now 8 combination 5 into p to the power 5 into 1 minus p whole to the power 8 minus 5. Similarly 8 combination 3 into p to the power 3 into 1 minus p whole to the power 8 minus 3. For 8 combination 5 we get the result this from 56, and from 8 combination 3 we also result is 56. Okay, and therefore p to the power 5 1 minus p whole cube, p cube into 1 minus p whole to the power 5. Now this 56 and this 56 are cancelled. Now p to the power 5 and p cube are cancelled, comes to p square, and 1 minus p whole to the power 5 by 1 minus p whole cube equal to 1 minus p whole square. Therefore p square equal to 1 minus 2p plus p square, therefore 2p equal to 1, and therefore p equal to half, and q equal to also half. Now we come to our next part, that is the experiment is repeated 6 times. What is the probability of obtaining 4 success? So here n is changed, n comes to 6, and favorable cases is 4. So probability of 4 is 6 combination 4 into half to the power 4 into half to the power 6 minus 4. So it comes to 15 by 6, 64. Okay. Next come to my last problem. It is also a back calculation. Okay, through mean and variance. For a binomial distribution, the mean is 3 and the variance is 2. Okay. Find the value of n and p. Here find the probability that x, the variable value, is 5. So for binomial distribution we know mean equal to np and variance equal to np cube. Therefore mean equal to 3 and variance equal to 2. Therefore variance by mean equal to 2 by 3 we put, and therefore np and this np are cancelled, and we get 2 by 3. Q equal to 2 by 3, and therefore p equal to also 1 by 3. And np, we know np equal to 3, therefore putting p equal to 1/3, n into 1/3 into 3, therefore n equal to 9, and n equal to 9 and p equal to 1/3, therefore probability of 5, the second part of our question, equal to 9 combination 5, 1 by 3 whole to the power 5, 2 by 3 whole to the power 9 minus 5. Okay, so therefore it comes to 224 by 2187. Okay, hope this back calculation you also understood. In conclusion, what I am saying, that again it will be applied in case of repeated trials. The trials are independent and outcomes are divided into 2 categories, success and failure. This is the main point to remember for applying binomial distribution. Okay, hope you like this video. comment in case of any queries. Don't forget to subscribe and click the bell icon to get my next video. Thank you.